Hi folks, welcome to the EGXW info group of Twitter accounts YouTube channel, and today I want to talk to you about flight tracking software. It's a video I've been wanting to do for ages, and to be honest, looking at our website statistics, most people come to our website looking for information on how to track aircraft or flight tracking software. So we're going to dive in and see what we've got. Here we've got 6 providers of flight tracking solutions. Now I like to refer to flight trackers as blocked or unblocked, and you're about to find out why. The top 3 I would categorize as blocked providers. Now that is because they actively block out military aircraft, and we're a military aviation enthusiast website. We're going to be primarily focused on military aircraft. So the top 3 tracking services aren't going to be for you if you're interested in military aircraft. Now that's not to say some military aircraft don't slip through. For example, I zoom in here, we can see a military aircraft there. So they do slip through time to time, generally because they've managed to skip through a filter due to one technical reason or another. Other people, anyone can also apply to have their aircraft removed from the service as well. So particularly users of that function, their business jets and celebrities, they may say, look, I don't want anyone to know where I'm flying, so please can you remove the tracking on your website for my aircraft, and they'll do that for you. So that's why I refer to those top 3 as the blocked providers, and the bottom 3 as the unblocked providers. That is because pretty much they do not block out any traffic whatsoever, and that's exactly what you want when you are following military aircraft. Now there are advantages of the top 3. Okay, so if for example you want to follow your family member on holiday on their favourite airliner travelling out to Magaluf, you want to be following them on one of those top 3 because that is their niche, that's what they are there for, and their business model is to sell their flight tracking solutions to the airlines and fleets. So they're going to be good at worldwide coverage, and they're quite good at low level coverage as well. So that is the benefit of the blocked providers. Now they also do a few tricks particularly that I've noticed. So whereas the bottom providers will generally show you exactly where an aircraft's tracking now, the top 3 tend to use some tricks and they use things like route predictions and predictions over time to plot aircraft they're not actually getting a signal from. So you can be watching an aircraft flying over, say, vast expanses of water, and you're thinking that's live, that's exactly what's going on now, but in reality they're just using a calculation from point A to point B and where that aircraft should be. It may well not be there, it could have turned round for all we know, and you would not know because they use predictions to predict where aircraft are, as well as combining that with real traffic data. So you can sometimes get caught out with these little tricks of the trade to make aircraft appear on the map when really it's not fed from live data. They also have quite good ground coverage. They actively send out receivers and fund them for remote areas of the world where they need tracking services. Okay, FlightAware seems to have gone down when I filmed this video. I think that's a technical problem at my end and nothing to do with the service. Okay, so they are all up and running at the moment. So there we go. Right. And like I've said, the commercial model of the block providers is to sell them to fleets and airlines, their solution. Okay. What I want to focus on is these unblocked providers at the bottom. We have 360 Radar on the left, we have Freedar in the middle, and ADSB Exchange on the right. And they are the main 3 players in the unblocked tracking market, so to speak. you will find that all three of those are based on Virtual Radar Server, which is an open source program for flight tracking. Indeed, preloaded here. Let's get rid of my bookmarks toolbar because I'm using vital screen space. So we've got Virtual Radar Server, and this is an open source application that people can use to make their own flight tracking. And indeed, you could make your flight tracker by downloading Flight Radar and hosting it on the internet for other people. It's not going to be anywhere as good as the providers at the bottom because of things like coverage and technical aspects that we'll get into a little bit later, but you could do that if you wanted to. Right, now because they're based on Virtual Radar Server, they offer quite a lot of alternatives. Now I believe I'm right in saying all of these three bottom providers here, the unblocked ones, in fact let's get rid of the blocked ones because we're done talking about them. So the unblocked providers have taken Virtual Radar Server and added to it in terms of resources, i.e. computing power, and also added it to with their own custom code, particularly to affect the look as they developed their service. Now, first of all, I'll talk about 360 Radar, but I'll give you a bit of a warning here, a bias warning. We chose to endorse 360 Radar as our tracking service of choice a few years ago on our website. Now, I don't want you to think that I am bound to 360 Radar or we get any benefit from that whatsoever. We get no benefit from 360 Radar for endorsing them because we want to remain independent. If a better player comes along, I want to be able to change that recommendation and make sure all my followers find the best service for tracking military aircraft, because that's what we want. So we receive no benefit for them whatsoever. The only caveat to that is when we raised money for our new PC after it blew up, 360 Radar did make a donation to us. However, that was not in exchange for anything. That wasn't in exchange for a good review, more coverage on the website, anything like that. And 360 Radar don't even know we're going to be making this video. Okay, so I just wanted to be totally open and honest, so you know that I'm not biased towards them because I'm receiving any kind of benefit. Okay. Now, I would say 360 Radar is focused on the UK. They want to be the best in the UK, and because of that they have the best, in my opinion, low-down coverage. They focus on getting receivers out into key locations, and particularly they've been sending out free receivers to like the remoter areas of Scotland, bringing in some great coverage recently. Now there are some downsides, and again this is my opinion. Some of their charts are quite out of date. We used to have a weather radar overlay that many people found useful, but that disappeared a year or so ago, and we keep getting promises that it's coming back maybe a week or so, but as yet it hasn't appeared for all users to use. They do use other sources of data, not just ADSB or Mode S, as we'll talk about later, but they have incorporated things like Flam, which is a glider, mainly glider based transponder. BBMF also use Flam, so very useful. Things like gyro, satellite tracking, and AIS, which is basically transponders for boats, and they've incorporated that into 360 Radar. However, due to various issues, sometimes it works, sometimes it doesn't, sometimes it comes back for a while, sometimes it drops off. That's just me being honest, okay? So they've got really good innovative potential. Now the 360 Radar business model, and the reason I'm talking about business models here, because I think that really can give you an insight into these tracking services when you look at their business model and how sustainable their business model is, in my opinion, for the future. Now 360 Radar does two things. They have a subscriber model and a contributor model. Contributor model is if you send them data from your own ground station to help increase the coverage for everyone else, you get 360 radar for free. Great deal. And now if you are a subscriber, so you don't have your own data to share, you can get 360 radar for about £20 a year. And I'll just bring up the 360 radar website here. You can go to signup.360radar.co.uk, click try it now, and you can get 3 months access, £6.99, or there you go, £22, £21.99 for 12 months access. Personally, I think that is great value. You know, you do the maths, you divide that by 12 months in a year, and you're paying less than £2 a month. I think that really is great value. And another thing, check out the frequently asked questions on their website. A lot of people ask these questions, and it can be, especially on social media, clogs up the feed with the same question over and over again, and could quite easily be answered by a quick look at the FAQs. Okay, I will go back to my notes there so I can follow it on. Okay, so ADSB Exchange we're going to talk about next. This is the one on our right. Now, they are focused on worldwide coverage. See here, we're on New York. Pop over to the UK because that's where we're going to be focusing on. Let's see if my geography lets me down. So that looks like the UK to me. Now they've got good worldwide coverage. Okay. However, because they're not as focused on Great Britain, they don't get aircraft as low down. They just simply don't have that low level coverage that 360 radar does, in my opinion. Now, their business model is an advertising based business model, showing the ads in pop-up boxes, limiting your time on the site and generating new ads. That's their business model. Okay. Freedar, that's the other one of the big three. Freedar have done very well. They've come on the scene quite quickly. However, it's a free business model. Now, in my opinion, that isn't sustainable for the future. As more and more people use a site, they're going to be a victim of their own success, and they're going to need more and more computing power, and that computing power is not cheap. They're going to need quite a lot of servers online, and I don't know how they're going to pay for them. Okay. There's also, let me just grab my notes again. Yeah, one of the problems I've also found is they have quite a lot of downtime with servers going off. I think they run sort of a home server, and obviously subject to internet connection problems, power outages, code failures, and as I say, people develop their own code on top of virtual radar server to make these applications here. So that can sometimes cause problems in development. They also offer an app for iOS and Android. Now, that's great, however you don't need an app. You can just install a browser, direct that browser to your tracking service of choice, and all you need to do on your phone is just hit that browser and up will pop your desired tracking service. So you don't actually need an app. And I think one of the downsides with Freedar is they're going to have to spend quite a long time developing iOS and Android apps, which is going to cost time and money. And with a free business model, I just can't see that being sustainable. However, their long-term business plan might be to make it a paid service or advertising, get advertising revenue from it. So that's fair enough. I'm not privy to that. I will apologise if I've got anything wrong. I'm literally giving you my opinion as I see it from using these three services. And there are times that an aircraft will appear in one of these services over the other because they might have better coverage in a certain area. It's not 100% clear cut, and I would advise you to try out these services and see what you think. Okay, now that's the basics. and I'm going to start moving into some more complicated topics, so feel free to cut out at here if that's enough for you. Try these 3 unblocked providers. Obviously you can try the one in the middle, Freedar, and the one on the right, ADSB Exchange, entirely for free yourself, and see what you think. The only thing you can't do, obviously, is look at 360 Radar for free, but in my opinion it's well worth the investment. 360 Radar, and for less than £2 a month, if you're into your military aviation, that's where I would go, in my opinion. So for the more advanced user, we can start talking about the complexities of flight tracking and why some websites do better than the other by explaining things like transponder types. Now, different aircraft have different transponder types. Mode A transponders, they just transmit a 4-digit squawk code assigned by ATC, and because of that they're notoriously hard to track. That squawk code could be shared by another aircraft in the area as well. So how does the technology know if that's coming from which aircraft if all they are transmitting is the same code? That is why at present we cannot track Mode A aircraft, sometimes referred to as Mode AC. Now C is just the altitude signal, so A is the 4-digit squawk code, C is their altitude, and because of that they're notoriously hard to track. I know 360 Radar are looking into the development to see whether we can get some Mode AC aircraft tracking, but as yet it's not available to us. Okay, so the minimum transponder we need aircraft to have is Mode S. Now what's Mode S? Mode S is Mode A and C, so the 4-digit squawk code, the altitude, but also the aircraft's identity in the form of a hexadecimal ID code. Think of it like a registration number on a car. From that registration number on a car, we can look up the make and model in a database if we have our own database. The DVLA have them for cars, 360 Radar has their own database for aircraft, so does Freedar, so does ADSB Exchange. And they look up this transmitted identity code from Mode S equipped aircraft, and from that they are able to identify the aircraft. And because we identify the aircraft, they are unique identification numbers, so we can start to track them from there. It's all maths. So Mode AC aircraft we've talked about, that's your general aviation aircraft, but mostly mode A and C. Mode S, military users, I'd say 80% of military aircraft are Mode S, maybe 50% of general aviation aircraft, and a few airliners. But when we're talking about airliners, let's talk about the big boys. Most airliners have ADSB. Now ADSB is like a combination of Mode A, C and S, and also their location, and that is crucial. So they have the 4-digit squawk code of Mode A, the altitude of Mode C, their identity of Mode S, but also what the aircraft thinks its location is. And most airliners now have GPS equipped, so that's their GPS location. Perfect for tracking, and that is how we can track things using ADSB. Flam, that's another one I mentioned earlier. Flam is a transponder very much similar to ADSB. It sends out a location. However, it's a lightweight transponder and therefore is generally taken up by gliders and light aviation aircraft. But I also mentioned BBMF use Flam, very useful indeed. So if any of these services start to use Flam, that's going to provide you with an extra layer of tracking that you have against their competition. And indeed 360 Radar utilises Flam in their tracking. Now we've talked about hex codes and why that's important, but if you think about it, you've also got to make sure your database is up to date, and a good database is very important. Now if 360 Radar are dealing mainly with aircraft from the UK, it's going to be easier to keep that database up to date than focusing on the rest of the world. So that's a point you might want to remember as well. Now, we talked about Mode S aircraft. Mode S aircraft, they send out their identity, squawk and altitude, but they don't send out their location. So that needs to be worked out. And this is where these trackers come into play. MLAT is the key to that. MLAT is multilateration, so devising a location from a Mode S transponder by maths, triangulation. So triangulation, three receivers would be needed to accurately get a location. Now, for error checking and things like that, most of these sites will probably have a rule that a Mode S aircraft needs to be in range of 5 or more receivers on their network before a location can be determined. So this is where it gets crucially important. If we're tracking military aircraft, like I say, probably 80% of them are Mode S, we don't have a location for them, and now we need them to be in range of 5 or more transmitters. That is where good coverage really comes into play, and how we can reduce that ceiling down lower and lower, and we can track aircraft lower and lower. So that is crucial for low down coverage, because it is exponentially more difficult to track aircraft lower down due to line of sight communication. Now, one thing I will mention as well, where does ADSB Exchange get their data? Now, I don't know where ADSB Exchange gets their data, but there are some allegations out there, and like I say, they're only allegations. I don't know if this is true, but it's alleged that they get their MLAT data, multilateration data, from unwitting FlightAware contributors, people that contribute data to FlightAware, which was one of our blocked providers. Now, as part of the deal there, FlightAware contributors get multilateration data sent back to them. Now, if that user is also contributing to ADSB Exchange, all that multilateration data from all their FlightAware customers, contributors, could be coming straight into ADSB Exchange, and that could be how ADSB Exchange are actually tracking their aircraft with MLAT. So there could be quite a few unwitting contributors to FlightAware out there who are unwittingly providing data to ADSB Exchange. Now, again, that's just an allegation that's out there in the web, and it has got a lot of popularity, but I do not know that personally. I do not know if that is true or false. Now, we've talked about the challenges of tracking Mode AC aircraft. Now, contributing. You can contribute data. You can do that on a Windows PC, for example, or the more favourable option is a Raspberry Pi, that little mini computer. And if you pop onto our website, we have it's down here on the right hand side at Live Aircraft Tracking. Click that and we'll give you a rundown of what you need, and you can link there straight to, say, 360 radar with installation instructions on how to here we are, explain a bit about the installation, and then pop to this link here, and you go on to 360 radar's other site, lowflyingwales.co.uk, which has the instructions there on how to set up your own Raspberry Pi or Windows computer to contribute data. And as we see on our website here, it can be done quite cheaply. For example, if you have a Windows PC, you can buy one of these repurposed digital TV dongles that are excellent for receiving transponder data, and they can be had for as little as £15. So you could, if you have a PC that's running, say, all the time, you're decent with your computers, set up your own receiver for a one-off capital cost of £15 and get free access to 360 radar and probably many other providers as well if you wanted to share data to them. Alright, bringing my notes back up now. I only got so many windows. Okay. Also, you saw there with the receiver, it only came with a little stock antenna. So a lot of people like to upgrade their antennas, and they get great coverage with these antennas compared to that little tiny thing there, so bear that in mind. And of course, the better you position that antenna, maybe outside on top of your roof, the more aircraft you receive as well. Another topic I wanted to discuss is squawk codes. So as we discussed with Mode A, 4-digit squawk code assigned by ATC. Now for advanced users, squawk codes give you a great insight of what's going on. Here I have squawk codes on the bottom of my labels for 360 radar, and I can instantly translate those squawks because I'm used to seeing them and used to working with them. I can tell that he's speaking to Swanwick Military, he's speaking to RF Coningsby, he's not speaking to anyone. He's speaking to Lakenheath radar approach control, popping into Mildenhall. He's speaking to RF Wattisham. How do I know that? That's from the squawk codes. They are so important. And if you go onto our website and you drop down everything else and you go to SSR squawk codes, SSR secondary surveillance radar, there's a nice list there of what all these different who these different squawk codes are allocated to, and it's a great resource. And if you're particularly in our area around the Lincolnshire area, you can download our handy one-page squawk code guide here. And this is a one-page squawk codes that you can print out, stick next to your 360 radar, and instantly see who these people are talking to, and sometimes what they're up to. For example, Squawk 0020, that's an air ambulance helicopter on an emergency mission. Okay. And Squawk 23, again, search and rescue. You can instantly tell if a search and rescue helicopter's on a mission or not by looking at the squawk code 0023. Then it's on a actual search and rescue operation, and anything else it's not. So these are, when you start getting into the advanced things of aircraft tracking, squawk codes really are the key to knowing what's going on. Back to my notes again. So squawk codes, I do want to mention, take the time to mention some specific software. Now, in the earlier days of flight tracking, you needed specific software to track aircraft on your computer. And I just want to mention people like Plane Plotter, AirNav boxes and SBS boxes. There are still some users of those. I haven't used Plane Plotter for quite some time, so I don't know how good their network is, but there are software based solutions, and particularly Plane Plotter offers the advanced user a lot more functionality than 360 radar would. Now that does come with some downsides. Last time I looked at Plane Plotter, things like multilateration or MLAT wasn't automatic. You had to request an MLAT, and it was a little bit clunky. But worthwhile mention to those bits of software, if you're getting into the advanced side of air tracking, check them out. We'll also mention some exceptions like the red arrows, F-15s. They often turn off their Mode S output. They don't turn off their transponders because otherwise ATC might have a hard time looking for them. But particularly the red arrows and the F-15s like to fly with their Mode S turned off, as do other military users as well. So you won't see everything that's going on out there, and that is nearly always the question. The answer to the question, why can't I see so and so in the air at 10,000 feet? Limitations of Mode S versus ADSB, because ADSB is putting out there its location, every second or so, and Mode S has to be worked out. You'll sometimes see Mode S aircraft jumping around the map a bit, and because those plots aren't accurate to a GPS location like they generally are with ADSB, there's the speed, which is worked out from plot to plot over time, generally not very accurate as well. So take speeds of Mode S aircraft, say those Typhoons there, with a little pinch of salt. They're not going to be totally accurate as they say would be for your 787 flying through the air. Okay, so limitations of Mode S we've done. Limitations with third-party problems. Root databases, we've sort of touched on this again. You can have problems when these providers here link to other services. So say you're following an airline, and they'll often have a route, and that route information is provided by a third party. So that's down to them to how they keep up their route database. If they let their route database get a bit old and rusty, then because we're using that as a third party, the routes aren't going to be very good in this solution either. But there's not much we can do. Also, I notice we say here we've got some pictures of the aircraft. Again, that's a third party service, so those aircraft are provided by a third party. So sometimes you'll find those aircraft pictures aren't of the aircraft you're actually looking at, and you could be saying to 360 Radar, why have I got the wrong aircraft in the picture? Well, that's because we use third party databases to generate those things. Also, Virtual Radar Server is limited in its functionality. Now, as I said, a lot of these have built their own custom code on top of Virtual Radar Server to work with Virtual Radar Server as the engine behind them. But there are some inherent limitations, and there is some functionality excuse me, that people have asked for that would take re-engineering most of the code of their website to integrate a specific feature. So sometimes, you know, it's a cost benefit analysis too, and you know, I know Phil behind 360 Radars from a programming background, so he might be more adept at programming than they say the guy who owns ADSB Exchange, whoever he is, or I believe possibly Ben from Freeda. Sorry if I've got your name wrong. So down to the mercy of the skills of the programmer, really. And Virtual Radar Server does have some limitations as an engine. One of the problems that I often see clogging up Facebook groups is when someone's signed up for 360 Radar, they get on and they get a proxy error, 504 or 503. Now that 99% of the time you're getting a proxy error because you're not entering the username and password correctly. You may be using your PayPal username and password and not the specific one for 360 Radar they have emailed you with. You may be missing out the star or asterisk at the beginning of your password or something like that. So if you're getting a 504, 503 error, proxy error, logging into 360 Radar, is probably because your password isn't going in properly. Another complaint 360 Radar gets is that I have to type in my username and password every time. Well, that's actually down to the browser you're choosing to use. Things like Safari on mobile are notoriously bad at being able to store the username and password. Get around that by using a different browser like Firefox or Edge. I use Firefox on my iOS phone, and Edge as a backup, and they remember the password straight away. I don't need an app because all I use Firefox and Edge for is tracking aircraft on 360 Radar. So I just hit that as I would any other app, and up pops my password box with my username and password already entered. I click OK and I've got aircraft on my screen. Don't need an app, and you don't need to be typing in your username and password each time. Download a browser, even dedicate it for 360 Radar use, and don't use it for anything else, and that way you hit that browser, up pops your tracking. So there's no need for an app. Other things are, sometimes you'll see invalid hex code. Unfortunately, we haven't got any examples tonight of any invalid hex codes. But if I were to open up 360 Radar, I'm just using 360 Radar again because it's our preferred tracking service, and I know how to navigate around that very easily. So here's an example of a hex code. Click on that Typhoon. We've got a nice hex code 43C73E, and that will correspond in a database to that Typhoon. Sometimes aircraft will fly with an invalid code, and it's generally something like 000000, or 5 zeros and a 1, or 999999, or something daft like that. In fact, hold on, here we are, 00001. Now, that's a miscode. The International Civil Aviation Organization keep a database of aircraft identities and hex codes. That isn't valid. We're not going to get a response from our database to be able to tell us what that is, because that's programmed wrong. His mate over there, let's see if he's flying on there we go, he's flying on a valid hex code. That's why we've got his registration there. But this guy, he's not. We don't know who he is or what he's doing. Now, we can work it out because he's flying with another Osprey. He's got a call sign of XXX, which seems to be the call signs that the Ospreys are going in. We can look at his height and his speed and maybe even his squawk code, and we can work it out. But if that was flying on its own, you might not be able to distinguish it from an F-15, who often use miscoded transponders, or even some GA aircraft who use miscoded transponders. We don't know why they do it. Sometimes I've noticed that US Air Force particularly use it for security reasons, but often that can mean that they bypass Flight Radar 24's blocking. So where they would be more covert and blocked, all of a sudden they pop up on Flight Radar for the whole world to see. So sometimes it can be a bit short-sighted to pop in an invalid hex code into your transponder, because you don't know where in the database that's going to come back to. So that's worth mentioning. Invalid hex codes, yep, skipping blocks, unidentifiable, and I've talked about things like call sign, altitude, speed and location and routing to determine what that invalid transponder code could be. So that is our dive into flight tracking. Started off by talking about the 3 blocked providers, as I call them: FlightAware, Plane Finder and Flight Radar 24. Great for tracking your going to Magaluf for the summer, but not very good for tracking military aircraft. And then your unblocked providers, the big 3 are here, but because these are based on virtual radar server, if you type in virtual radar server, you're going to find loads of tracking services available. And an honourable mention to Donny Radar. I don't know if his website's up at the minute. I don't know if I've banged in the right address there. But this guy, really nice chap. There we go, look. It was me that was causing the problem, not him. Donny Radar, again, based on virtual radar server. He's got a receiver in Donny. He may have a few other receivers. It's not going to be like the hundreds that 360 Radar got. But this guy's developed his own website. He hosts himself with a live map based on virtual radar server, and he's tracking a Typhoon on approach at 1,850 feet. It ain't bad. So some honourable mentions to people like Donny Radar that have used VRS and created their own websites for people to see. They're not the big 3 players, they haven't got the commercial models or the business models of the other 3, but there's some notable providers out there. So I hope you've enjoyed our deep dive into flight tracking. It's, like I say, it's the most searched for term on our website is flight tracking. Hopefully you found it really useful, and I will just sweep up by saying one thing I've missed when I was talking about squawk codes. Where can you find it? On the Civil AIP ENR 1.6 ATS Surveillance Services and Procedures. Scroll down there, and this is the Bible for all your squawk codes, and this is the most up-to-date source, is the UK Civil AIP. So one thing I forgot to mention there, get yourself onto the NAT's website, get yourself signed up with a free username and password, use the AIP, learn about squawk codes, and geek out with me following miniature aircraft on flight tracking. Hope you've enjoyed it. Questions or comments in the description. It'd be great to get your feedback on it if you found the video useful, and I'll try and answer any questions you have, but hopefully I've done a good job with the video and covered as many as possible. Take care guys, see you in the next video.